Hello, and once again, my viewers, I appreciate you all. Today we want to learn a new thing. We want to learn physics. So today is when I'm starting physics. So please follow me step by step. As I have started physics now, make sure you are watching me and always just click on that notification bell and click on follow. If you are watching through Facebook, then if you are watching through YouTube, just subscribe to that channel, you understand, and hit on the notification bell so that you always be the first to see when we upload new video. So today I want to lecture you in chemistry, in physical quantity. So today we have what we call physical quantity. We want to be talking on physical quantities. So now let us start with the definition of physical quantities. What are physical quantities? Physical quantities are those quantities or those things that has measurable physical properties. You understand? Anything we can measure is a physical quantity. Anything we can measure at all is a physical quantity. Do you understand? Anything we can measure. Like for example, if I'm going to the filling station now to buy fuel, they will ask me how many liters do you want to buy. That liter is a measure of volume. Do you understand? So liter is the measure of volume. So they are giving me the measurement of the volume I want to buy. Now if I travel a distance, and I can be asked that distance you travel, like how many meters did you travel? You see that because the distance I travel can be measured, so distance is a physical quantity. That is a measure of length. Do you understand? Now if something is falling from a building or falling from a tree to the ground or to the floor, then they will ask me what is the height. So the height from where the thing fall to the ground can be measured. So that is why it is a physical quantity. Anything we can measure. For example, you can measure your length, you can measure volume, you can even measure the speed of a body. You can measure the speed. How can I measure the speed? If I can get the distance traveled by a body and get the time in which the distance is traveled, then I can measure the speed of that body. So anything we can measure is called, that can be measured, you understand, is called physical quantity. So that is in my last teaching I talked about physics, and you cannot talk about physics without talking about physical quantities, because physics is a branch of pure science that deals with matter and energy and how they are related with physical quantities. So physical quantities is a fundamental of physics. So if you must understand physics very well, then you must understand physical quantities. Now, physical quantities are of two types. They are fundamental and derived quantity. I said once again, physical quantities are two types. They are fundamental and derived quantities. So they are of two types. We have fundamental and derived. Do you understand? There are two types. We have fundamental and derived quantities. Do you understand? So now, what are fundamental quantities? Fundamental quantities are those basic quantities in which other quantities are gotten from. So by the combination of fundamental quantities, other quantities are gotten from. So they are the basic quantities in which other quantities are gotten from. So among fundamental quantities, we also have the major fundamental quantities. We also have the main among fundamental quantities. We also have major fundamental quantities. You understand? So what are derived quantities? Derived quantities are those quantities that are gotten by the simple combination of fundamental quantities. So you cannot have a derived quantities without having a fundamental quantity. You can't have a derived quantity without having a fundamental quantity. So fundamental quantities are those basic quantities, while derived quantities are those quantities that are gotten by the combination of fundamental quantities. Now we have about 6 fundamental quantities according to our scheme of work, according to our secondary school. We have about 6 fundamental quantities. Let me mention them. One is we have mass, we have length, we have time, we have temperature, we have electric current, we have amount of substance, we have luminous intensity. Okay, how many are there now? 1, 2, 3, 4, 5, 6, 7. Okay, so there are about 7 in number, and I think they are more than this. Just that I went to our secondary school. Okay, now look at this. These are the major these are the fundamental quantities that we have. Do you understand? They are fundamental quantities that we have. Now, among the fundamental quantities, there are also the major fundamental quantities. These are mass, length, and time. These three now are the major ones that you will always see anywhere in your physics. You always see it. You always see it. So, mass, length, and what? And time. Now let's start with what is mass. Mass is the quantity of matter contained in a body. So please, I want to advise you that as you are watching me, make sure you have it. Don't just watch me for watching sake. Get your writing pen, get your material. As I'm saying these things, you are jotting down. Anything you don't understand, pause and go back. Pause and watch it back. So try to get what I'm teaching, because whatever I teach will be standing on what I've taught before. So the next thing I'll be teaching now will be standing on fundamental and derived quantities. That is why you need to subscribe to our channel, so that you always see whenever we upload new video. So God bless you. Okay, now we said mass is the quantity of matter contained in a body. You understand? Then length is the point covered, the space covered between 2 points. That is length. You understand? Then time is that in which event is distinguishable with reference to before and after. It is that in which event is distinguishable with reference to before and after. You get? Okay, now and every physical quantity also have their physical units. Do you understand? Every physical quantity also have their physical units. Do you understand? Both fundamental quantity have their fundamental units. Derived quantity have their derived units. Do you understand? So fundamental quantity, the units of fundamental quantities are called fundamental units, while the units of derived quantities are called derived units. Do you understand? So now, because of a problem that science begin to have in giving units to quantities, now because of this, there is a body called international system body that organize themselves to agree on a particular unit for every quantity. So that international body is called System International Body, and the unit they give to every quantity is called System International Unit, and it is abbreviated as System International Unit, that is SI unit. So whenever you are doing every calculation in physics, it is very, very important that you put your unit. Do you understand? It is very, very important that you what? That you put your unit. Now when you solve every calculation in physics, when you miss to put the unit, you have failed a mark. Do you understand? So now every quantity has a unit given to them by the System International Body. Do you understand? That is called System International Unit. That is called SI unit or International System Unit. Do you understand? So now fundamental quantities also have their fundamental units. Derived quantities also have their derived units. Now fundamental quantities, for that of mass, for mass, the unit of mass is kilogram. Is what? Kilogram. That's the unit of mass. So kg, mass is measured in kg. That is for mass. So don't forget, we are still dealing with fundamental quantities. Then the unit of length is meter. Is what? Meter. So it is m. Do you understand? The unit, the SI unit for time is seconds. Time is seconds. is given as S, and the SI unit for temperature is Kelvin. Is what? Kelvin. Is Kelvin. So it is given in K. Now the SI unit for electric current is ampere. Ampere given as A. Do you understand? The SI unit for amount of substance, amount, is given as mole. Mole. So when we talk about stoichiometry in chemistry, we'll be talking about this. So now let's look at luminous intensity is given as candela. Candela. SC is given as what? Candela. So these are the units for all the fundamental quantities. Do you understand? These are the units for all the fundamental quantities. Now let's look at derived quantities. Derived quantities, as we know, are those quantities that are gotten by the simple combination of fundamental quantities. Do you understand? So now we want to look at some derived quantities and their derivation. Do you understand? Now look at this. And every derived quantity have their derived unit. So if fundamental quantities have their fundamental unit, then derived quantities also have their derived unit. So when we are solving for derived quantities, we also derive their units. Now example of derived quantities, area. Area is a derived quantity. Mathematically, area is given as length times width. Is given as what? Length times width. Do you understand? So area is given as length times width. Understand? Or length times breadth. It is given as length times width or length times breadth. You understand? So now, no matter how it is given, whether it is length or it is width or it is breadth or it is height, all of them are measures of length. Do you understand? Now let us look at how can we get the unit of area. Now if the formula for area is length times width, then what about the unit of area? Now we can derive the unit of what? Of area. Now look at this. If length is measured in meter, don't forget, meter, that is L, times width is also a measure of length. The difference is their direction. You understand? Width is going horizontally, the other one is going, the other one is also going horizontally in the other direction. Another one is going vertically, that is height. You understand? So now no matter how they are given, they are all measures of length. Do you understand? So now width is also meter. It's also meter, that is M. Are you seeing it now? So it is now the, so if the unit of length is meter, the unit of width is meter, then the the formula for area is length times width. Therefore the unit of length of area, will be meter times meter. Then meter times meter, which is M times M, is equal to what? Meter square. Or square meter. Or squared meter. Do you understand? So that will say that the unit of area is squared meter. Do you understand? So that's the unit of area. Now let's look for volume. Then we have volume. The formula for volume is also a derived quantity. Are you seeing that for this area now, we have to get the length and get the width. And length and width, they are all lengths. You understand? They are all measures of length. Are you seeing it? So combination of two lengths is what is giving area, which are combination of two fundamental quantities is now giving an area. That is why area is a derived quantity. And the unit of area is meter squared. You see how that is squared meter. You see how we got the units. The next one, we'll be looking at volume. Now, look at the unit of volume. Volume is given as length times width times height. Isn't it? Or length times breadth times height. That is volume. Length times width times height. or length times breadth times height. Do you understand? Now, no matter how it is, whether length whether width whether height they are all measures of length. Do you understand? They are all what? Measures of length. Now, look at this. This is length. Length is meter times meter times meter. Now, you now see m times m times m. You will notice that now from here we can derive the unit of volume. So if the formula for volume is combination of three lengths, now the unit of volume will be length meter times meter times meter, which is cubic meter. Cubic meter. So that is how we got the unit of volume. It is what? Cubic meter. Now the next thing, let's talk about the unit of velocity. When we talk about velocity, now before I can get the velocity of a body, I will first of all get the distance or the displacement, you understand, traveled by that body. Then I will get the time in which the displacement is traveled. Then I will divide the displacement or the distance by the time of traveling. Then I will get the speed of that particular body. Now look at this. Speed and velocity are the same thing, just that the difference is that speed is a vector quantity and the difference is that velocity is a vector quantity but speed is a scalar quantity. Do you understand? Speed is a scalar quantity. Now speed is dealing with distance but velocity is dealing with displacement. So now distance and displacement are the same thing, just that difference between distance and displacement is that in displacement distance is traveled and there is a direction that is specified. That is in displacement distance is traveled with a specified direction. In displacement it is a distance in which the direction is specified, but in distance there is no direction that is specified. So that is the difference between a distance and a displacement. So but in calculation velocity and speed are interchangeable because they are just saying the same thing and they have the same units and they have similar formula. Now for speed, let me deal with speed. Speed is giving us distance over time. So speed is the rate of change of distance with time. That is the distance traveled with the time taken to travel the distance. That is speed. The next one we're talking about is how we can get the unit of speed. Now look at speed. If speed is distance over time, that is distance traveled with the time. Distance traveled with the time. You understand? That is to say, we know that distance is also a measure of length. You understand? When I travel a distance, it is also a measure of length. Distance is also a measure of length. Do you understand? So now, distance is given as, let me use it as length times time over time, length divided by time, because distance is a measure of length, which is a fundamental quantity, and time is also a fundamental quantity. So you now see that how we combine length and time to form a derived quantity, which is speed. Do you understand? Now let us get the unit for speed. This is the unit of speed. Speed, since it is given as length over time, so length is in meter, all over time in seconds. Don't forget that time is seconds. The unit of time is seconds, and the unit of length is meter. Do you understand? So we can call it meter over seconds or meter per seconds. This is what? Meter per seconds. The unit of speed is meter per seconds. But one confusion we'll be having here is that you will not be seeing this in many occasions. You will not be seeing this like this in your textbooks. You'll be seeing it like this. You'll be seeing it like meter per seconds. This is how you'll be seeing it. Do you understand? Now, this thing you are seeing now is the same thing as this. They are the same thing. Just that this is gotten by indices. This is indices. In our mathematics, we were taught indices. You understand? So, and which I'm going to do the video very soon. Indices. When I'll be teaching indices in mathematics. Now look at this. This thing now is meter per second. It is the same thing with this. Do you understand? Now let me tell you how this thing came to be like this. Now look at this. From our indices, we were told that a raised to power minus 1 is equal to 1 over a. This is what we were told in our indices. Do you understand? And we were also told that in our indices that a raised to power minus 2 is also 1 over a raised to power 2. Do you understand? So we were told this in our indices. So now, that is the, and we are told in fraction, in mathematics, in fraction, we were told that that a over b is the same as a times 1 over b in fraction. If you can go back to your JSS1 or your SS1, JSS1, JSS2, JSS3, when you did fraction in your secondary school, you come to understand this, that a over b is also the same as a times 1 over b. Now, if a over b is a times 1 over b, therefore we can also say that m over s is equal to m times 1 over s. Are you seeing this now? We can also say that m over s is also m times 1 over s. Do you understand? We can also say that m over s is also the same thing as m times 1 over s. Now, according to our indices, since we were told that 1 over a is equal to a raised to power minus 1, we can also say here that this s, 1 over s, is also the same as s raised to power minus 1. Are you seeing it? So since we were told in our indices that 1 over a is a raised to power minus 1, we can also say that 1 over s is s raised to power minus 1. Do you understand? So now, if 1 over s is s raised to power minus 1, and m is multiplying 1 over s, so we now have that this is also giving us m times s raised to power minus 1, which is this m now multiplying this s raised to power minus 1, which is now giving us, and we know from our mathematics that a times b is equal to ab, and a times c is equal to ac. So therefore, we also know here that m times s raised to power minus 1 is equals to ms raised to power minus 1. Are you seeing this? So this is how this thing you see here was gotten. So this is where we are ending today. Remember, I remain David Chukwumezie. If you have not subscribed to our channel, subscribe to that channel and click on the notification bell so that you will always be the first to see when we upload new video, and you will always be the first to watch it.